Hello friends. So in today's question, the coefficients of friction between the three blocks and the horizontal surface are mu s as 0.25 and the kinetic friction coefficient is 0.20. The masses of the block MA and MC are 10 kg and MB is 5 kg. Knowing that the blocks are initially at rest and that C moves to the right through 0.8 meter in 0.4 second, determine the acceleration of each block, the tension in the cable and the force P. So this is the figure. We have block A, B and C and force P is being applied on block C and the coefficient of friction between all the surfaces, static is given as 0.25 and kinetic is given as 0.20, and M mass of A and C is 10 and whereas mass of B is 5 kg. So first of all, we are going to find out the constraint of the cable. We can say that constraint of the cable. So the constraint of the cable. Now if we try to force C towards the right, so there will be a displacement on A which will be relative to XC, and at C is also connected with B, so there will be a relative motion also between B and C, and B is independent, is also connected to this wall, so it is going to have an independent, you can say, extension in the cord. So because of the relative motion of between A and C, we can say that as it has 1, 2, 3 connections, so this will be 3 XC minus XA, and next will be relative motion between B and C, so this will be XC minus XB, and last there will be the B because of this fixed connection, so this will be plus minus of XB, which is equal to constant. So if you differentiate this equation twice, differentiating equation twice, so we can get this as 4AC minus 2AB minus 3A is equal to 0. Let us call this equation number 1. Now we are going to consider individual block A, B and C and trying to sort out what are the various forces acting on it. Okay, so we can say for block A, for block A, and so this is our block A. It is going to move towards right side with the acceleration of A, and it has 3 cables, and let us say this is T, T as well as T. So there will be friction in the backward direction, then let us call it FRA, and we are going to have MAG in the downward direction, and there will be normal NA which is acting in the upward direction. So these are the forces which is acting on it. So we can find out our FRA will be equal to mu kinetic into NA, and the kinetic value mu K, and NA is our MAG, this is MAG. So we get what is our friction FRA. So we can write the equation that 3T minus FRA will be equal to MA and AA. From here we can write the equation of acceleration, that acceleration of A is equal to 3T minus substituting value of FRA, that is mu K MAG divided by MA. And we already know the values, so we substitute the value, we get A, this will be 3T, and MA mass is 10 kg, so we can, this is minus mu K is 0.20 and mass is our 10 kg, and we have G, that is, let us keep it at G as it is, and divided by 10. From here we can say our acceleration AK is equal to 3T divided by 10 minus 0.20 G. Let us call this as equation number 2. Now similarly we are going to draw for block B. For block B, so this is our block B. Okay, so we have tension and a friction force, let us, it is FRB, and it is going to have MBG, and let us say the normal is acting, that is NB. So we can find out our FRB, which will be equal to mu K into NB. We substitute value of NB, which will be equal to MBG. So FRB is equal to mu K MBG. And it is also moving in this direction with the acceleration of AB. So we can write the equation as 2T minus FRB is equal to AB, and we can write that our acceleration of B, AB, is equal to 2T minus FRB is given as mu K MBG divided by MB. We substitute the values, we get AB is equal to 2T divided by 5 minus 0.20 G. Let us call this equation number 3. And the last is block C. You can say for block C, for block C, a force is being applied towards right, that is P, and it is having a tension 1, 2, 3 as well as 4. So this will be combining as 40, and we will have a friction force, let us call this FRC, and we have downward, that is MCG, and in the upward direction, let us say normal NC. We can find out that FRC is equal to mu K into NC, and we put the value of NC, which is equal to MCG. FRC is equal to mu K MCG. It is moving towards right side, with the extension of C, AC. Okay. So we can say P minus 40 and minus FRC is equal to MC into AC. So from here we can find out our AC. AC will be equal to P minus 4T, and this is mu K mcg divided by mc. We put the value of, we get AC, okay, and this is P minus 40, mu K is 0.2 and MC is given as 10 G and divided by 10. Finally we can write our AC is equal to P minus 40 P by 10, 4 by 10, and minus this will be equal to 0.2 G, and let us call this as equation number 4. Now it is also given that C moves towards the right through a distance of 0.8 meter in 4 seconds. Okay, so we can use the equation of kinematics for equation C, for block C, using equation of kinematics for block C. Okay, we get the distance moved by block C is given as xc, which is equal to initial coordinate x is 0 plus initial velocity vc 0 and plus half acceleration ac and time t square. Okay. And this can be written equal to as half AC t square and sorry, I missed one thing. So we get this as AC from here, initial velocity is 0, we have x naught, so we can say that our this AC is equal to xc minus xc naught, and this will be minus of vc naught divided by t square, and this whole term is multiplied by 2. Okay. So we can write this will be equal to 2, we have moved towards the right of 0.8 meter, so we have this coming as 0.8 and divided by time is given as 0.4 whole square. So from here we can say that AC is coming equal to as 10 meter per second square. So we had two options, either we can calculate or rather find out AC by using equation 4, but with the help of this equation we cannot further solve it as it will be creating a further unknown. So what we do, we use this equation AC or kinematic equation for block C and find out that value of AC is 10 meter per second square. Okay. Now we already know the equation 1. Equation 1 was the equation for the acceleration. So we say that from equation 1 we get 4ac minus 2ab minus 3a is equal to 0. We substitute value of AC, AB and A in equation this. Okay, so using equation 2, 3 and let us call this as equation 5 and 5, we get this as 4 into 10 minus 2, and our AB was 2t divided by 5 minus 2g minus 3, and A was our 3t divided by 10 minus 0.20 g. Okay, and this was equal to 0. So if you solve it, this will be coming equal to as 40 minus 1.7t minus 2g is equal to 0. And from here we can say our t is equal to 40 minus 2g divided by 1.7. We put value of g as 9.8 divided by 1.7. So we can say our tension T will be coming equal to as 29.29 newtons. So this will be our tension T, and from equation 4 now we use the equation 4 and to find out value of P. So from equation 4 we have AC is equal to P upon 10 minus 4t divided by 10 minus 0.2 G. From here we can say our P is equal to, rather P by 10 is equal to AC plus 4t divided by 10 plus 0.2 G, or we can say that P is equal to 10 times AC plus 4t divided by 10 plus 0.2 G. When P is equal to 10, AC was our 10 plus 4 into 29.29 divided by 10 plus 0.2, 29.8. Okay. So if you solve it, the force P will be coming equal to as 236.8 Newton. So this is the value of the force, and now we can find out our acceleration A. Okay, so acceleration of A, we use equation 2. From equation 2 we can say our acceleration of A is equal to 3 into tension 29.29 divided by 10 minus 0.2 into 9.8. So we get acceleration of A is equal to 6.86 meter per second square. And last is our acceleration of B. Okay, so we use equation 3. From equation 3, AB is equal to 2 into 29.29 divided by 5 minus 0.2 into 9.8. From here we can say the expression of B is equal to 9.75 meter per second square. Okay. So we found out all the accelerations, and okay, the direction we can say AB also will be towards the right, A will be also towards the right, and our AC will be also towards the right. So these are our value of accelerations as well as tension and the applied force. Okay. Thank you.